chemistry calculations for composition is molar mass. So by the name, you know if we're dealing with mass, we're going to be doing something with grams. And we are going to need the periodic table. The masses on the periodic table are technically in atomic mass units, where, let's look at a periodic table. Here we go. Okay, if we have boron, because it's right there, 10.81 atomic mass units. It's the mass of one boron atom. That's nice. However, it's not very useful. What's useful is to think of that in grams. And 10.81 grams of boron is 1 mole of boron. So the atomic mass is the molar mass for one element. So if we have a compound, all we have to do is add up the masses. Now, I want you to take masses off the periodic table. To 2 decimal places. So always round to 2 decimal places. So you look at our first example. We've got sodium chloride, 1 Na and 1 Cl. So, not very focused. There we go. See chlorine, 35.453. Sodium, 22.98977. We're not going to use everything. We're going to round to those 2 decimal places. Add them together, and now that's the mass of 1 mole of the compound. Now, how do we do subscripts? Well, in carbon tetrachloride, we've got 1 carbon and 4 chlorines. We know we have 4 chlorines because of the subscript of 4, so we are going to multiply that mass of chlorine that we get from the periodic table by 4, because there are 4 of them, and then we added our total mass of carbon to our total mass of chlorine. Now, adding molar masses is very, very important because we're going to use it in a lot of different applications. So here are 2 for you to try. Pause this and try it, and then check yourself. We've got calcium, 40.08. We've got carbon, 12.01, but that subscript of 2 distributes. So we have 2. And nitrogen, which when we look on the periodic table is 14.01, we also have 2 of them. So we need to add those 3 masses. And we get 92.12, and the units are grams per mole because it's the number of grams per 1 mole. If we have this one, carbon is 12.01, but we have 8 of them because of the subscript of 8. And hydrogen is 1.01. We have 18 of them. So we add those together. and we get 114.26 grams per mole. Now, what is the molar mass of magnesium nitrate? Well, the first thing you have to do is remember that magnesium has a +2. Nitrate is a polyatomic ion, NO3 with a -1 charge. So you have this formula. You have to have a formula to do a molar mass. You can't do it from a name. So we use the periodic table. There's magnesium, 24.305, so we use 24.31. Nitrogen, 14.01, and there's 2 of them. Oxygen, Oxygen, 15.9994. So when we round it to 2 significant digits, 2 decimal places, it's 16.00. And we have 6 of them because the 2 outside the parentheses times the 3 inside the parentheses. So we're adding up the magnesium, the nitrogen, and the oxygen. And we get 148.33 grams per mole.